Hey guys, welcome to 9.3. 9.3 we're going to be talking about graphs, but we're going to be looking at them a little bit differently. So what I have here is graphed is this y equals x squared over here on the left, and that's what we're going to call the parent graph. So that's where you have a quadratic, but there's nothing specifically special happening other than it's just simply an x squared. So next I'm going to look at what happens if I add a negative sign, and that's this one here that I just highlighted. Notice all I've done is add a negative sign, and watch what happens to the graph. Let me kind of center it here. Watch what happens to the graph when I graph it. It just turned it straight upside down. So that's all the negative sign on the left does. So now let's check out on the next one. It says plus 2. So let's see what happens to it. Looks like it moved it up 2. Here, let's play with it a little bit. What if I make it minus 2? Moved it down. So if you add or subtract a number on the outside of the x squared, it moves it up or down. Exactly where it says it goes. If it says minus 6, well, look at that. It went down to negative 6. But now let's move that 2 inside a set of parentheses. Let me change this to how we had it. Do you see the difference between number 3 and number 4? They both say minus 2, but on number 3, it's on the end, and on number 4, it's inside the parentheses. So what happens? It moved it right. What happens if I make this a plus sign? It moved it left. Let's make it plus 3. 5. 6. Okay, so this one is going to move it left and right. However, you'll notice that it moves it the opposite direction of what you'd think. If it's minus 6, it actually moves it right 6. And I'm going to explain to you why that works here in just a second. But first, let's go ahead and talk about what happens if I put this multiplier out front. So now I have a 2. It's multiplying the x squared. And what do you see? Boom. Looks like that. So how does this work? First of all, when you have a graph, this parent function here, notice that it actually goes through I'm looking at the red one, the vertex, and I graph it over, it always goes up 1 over 1. Can you kind of see? It's really hard for me to do that with my finger. But basically, it goes up 1 over 1 on both sides. That's what it looks like normally if nothing special is happening. But if you add a multiplier or something to the outside, that's where things will get different. This 2 made it look more skinny. Let's try making it 22. Look, it made it even more skinny. There is a way to make it wide, and that's by making it less than 1. Now it's down like that. Let's see if I make it 0.02. Look, it got even more flat. Although notice that it still is a parabola, it's just a really fat one. So we're going to use the words stretched and compressed, and the turning point is actually going to be at 1. Watch what happens if I just make this 1. Literally nothing happened, right? Like it's just exactly on top of the normal graph. So if you ignore the negative sign, and that value out front of the x squared is bigger than 1, it's going to stretch it because it's stretching towards the ceiling. Think about if I put my arms in a parabola shape and I stretch towards the ceiling, it would make my arms skinnier. If you make it less than 1, and again, I'm ignoring negative signs. If you make it less than 1, then it will be, we call it compressed. And here's a big mistake I see a lot. If I make this 3, okay, I can see that it does not go through the up 1 over 1 on either side. I can see that it is skinnier, but I will have maybe this negative 3, and people will tell me that, well, it's compressed. No, because if I take this up here, and let's make it negative, you see how it comes down 1 over 1, down 1 over 1 again. It's really hard for me to get them exact, but you see how that's where those end up? The black is still skinnier than the red, so it is still stretched. Again, when you see that negative 3, ignore the negative sign, just look at the 3 and see that it is stretched. So what's kind of fun then is I can say, okay, If I want you to give me a graph, let me erase this. This is an old example. Let's say I wanted you to give me a graph that moves right 2 and left 3. Well, I would start by saying, well, moving it up and down, we saw that on this one, where you have to put it on the outside. So if you want me to move it up 2, then I need to put plus 2. Make it so you can see it. There you go, it went up 2. And you said you wanted it left 3. Well, we figured out on graph 4 that that's what it takes. Zoom out so you can see it. That inside those parentheses is what it takes to move it left and right. So I guess I'll put, oh, if you want it left 3, it's opposite of what you think, so I should put plus 3. There you go, it moved it. So why does it work that way? I'm going to have to make a second video. Hang on.